us at the Metaverse Summit. So thrilled to talk to you today here about enabling a cross-chain metaverse with XCM. So today we're going to cover a lot of ground. You're going to learn about Polkadot, Moonbeam, and then of course XCM, which is cross-consensus messaging. So my name is Kevin NEILSON. I'm a developer relations engineer at Moonbeam. Hold it closer. Sure. Yeah, so as I mentioned, we'll talk a bit about Polkadot. We'll start with an introduction, and we'll also look at Moonbeam and, of course, XCM. So let's do a quick introduction to Polkadot. You may already know about it. Polkadot is a layer 0 blockchain, and Polkadot work on it started in about 2016. So Gavin Wood was a co-founder, as was Robert Habermeyer and Peter Zabin. And when they started working on it in 2016, at the time, it was kind of a contrarian belief, that the future would be multi-chain. It wasn't obvious as it is now, or as clear as it is today. So back in 2016, they kind of took the approach that we're going to be moving away from a world where we just have a single, blockchain where we're trying to fit everything through, and instead we're going to have many different blockchains. And depending upon what use case you're looking for, you might want certain considerations built into the properties of the chain, right? Depending upon if you're looking for more privacy. Maybe you're looking for faster throughput because you have a game. Maybe you're looking for extreme decentralization because you have high-value assets or something like that. So the idea of Polkadot is to provide a place for developers to launch these different blockchains, customize them, make them unique to their particular use cases. But let's just find a way to connect them all, right? So Polkadot is a layer 0. And so if you're launching an application or a game or anything like that, you're typically not going to be launching it on Polkadot itself. You're going to be launching it on a layer 1 that's on top of Polkadot, such as Moonbeam. And so parachains is what Polkadot calls these layer 1 blockchains. Parachains is just a complicated word for a layer 1 blockchain. But these blockchains provide specific functionality. So again, it could be privacy, it could be decentralized storage or decentralized identity, or many different things. But the way to connect all of these different parachains is through XCM. So we don't want these different layer 1 blockchains to be an island. We don't want you to be trapped on any individual blockchain. We want you to be able to benefit from the features of the other chains that are on Polkadot. And so that's where XCM comes into play. And I'll explain exactly how XCM works and why it's so powerful. But first, let's do a quick introduction to Moonbeam. So Moonbeam is an Ethereum-compatible layer 1 parachain on Polkadot. And it's built with Substrate, which means that its architecture is very different from that of Ethereum. However, the end-user experience and the developer experience is quite familiar, if not better. And we don't just provide an EVM and call it a day. So we start by providing a fully Ethereum-compatible Web3 RPC. So that means you can make a request to a Moonbeam node that's the exact same one that you'd make to an Ethereum node. You could say something like ETH get balance. You don't have to change the parameters or the units or anything like that. And you can get back exactly what you'd be expecting. The only things that wouldn't make sense is Moonbeam is a proof-of-stake-based protocol. So if you were asked for difficulty or something like that, you'd get back a default value. We also have a unified account structure. This is very important in the context of Polkadot because we inherit some very powerful features of Polkadot, including things like on-chain governance. And so if you'd like to participate in these Substrate features, you need to have a Polkadot address. And so Polkadot has a different account format, a completely different private key, and it's not the case that you can just map one to the other and have it work seamlessly. So we made the decision early on that we needed to develop something where this would be possible and make it possible for you to have a single account. And so we did that. It was a big engineering lift early on, but we've made it so that you only need to have one Ethereum account, one Ethereum private key, the same one that's in your MetaMask, and you can interact with Moonbeam, both the EVM, and also participate in Substrate native features on Polkadot with that same account. So that's very, very important. And we also have a huge host of developer tools and integrations. So for any Ethereum dev, you're used to working with Hardhat, Truffle, Remix, Scaffold ETH. Whatever tools you're used to working with, you can use them with Moonbeam. And that's because of our seamless Ethereum compatibility. And these are not forks or clones or there's not some sort of crazy setup. You can use these tools straight out of the box. And that's thanks to Moonbeam's seamless Ethereum compatibility, because we stay as close as possible to the Ethereum developer toolset. So before I go any further, I want to clarify the distinction between Moonbeam and Moonriver, as well as Polkadot and Kusama. So you may already know, but Polkadot is a layer 0 blockchain, right? It's a production mainnet, but so is Kusama. Kusama is also a layer 0 production mainnet. So what's the difference between the two? Well, Kusama is meant to be more of an experimental mainnet. It's meant to be one where you can take risks and validate your ideas in a production environment with real economic value. So that means that all of the latest protocol code for Kusama always ships after the testnets, first to Kusama. And another thing to keep in mind is that on Polkadot, you have to bid essentially leases for your blockchain. So your community or your team has to lock up sufficient DOT or Kusama in order to run your layer 1 blockchain. And so if you're trying to run a blockchain on Kusama, it's a bit cheaper, right? So it's easier to secure a slot. So that's definitely something to consider. Polkadot and Kusama are brother-sister networks. And teams may choose to deploy to one or the other, sometimes both. And so Moonbeam and Moonriver, we've taken this similar approach of being brother and sister networks where, again, the latest protocol code ships first to Moonriver and then to Moonbeam. And so teams might say, we're going to deploy to both, we're going to deploy to one. We've seen both. So let's talk about why we're all here, which is XCM. And XCM stands for cross-consensus messaging. And cross-consensus messaging is very, very powerful. It enables a number of things, including being able to send assets to other chains, being able to take actions on remote chains, and much more. But let's talk about the specific format of exactly what it is, and we'll dive into a bit of the technical details. So XCM, at its core, is just a specification for constructing messages. You can think of it as a language. It allows blockchains to talk to one another and make themselves understood. And just like human language, the reason we have specific languages is so that people can understand what we're saying and that there's no ambiguity in terms of what we're conveying. And it's the same thing with XCM. These messages to chains, it's not just, hi, hello, how are you doing? It's important things like, please transfer this amount of value, or please stake my tokens on this chain. And so XCM, again, is a generic message spec. So it's very open-ended. It's very powerful. You can do a huge amount of things with it, but you have to be very specific in terms of what you'd like to do. You have to be very explicit and a bit pedantic in explaining exactly what you'd like to do. Now, for most developers, you're not going to be constructing an XCM message manually. You'll be relying on tools like Solidity interfaces or precompiles that help you construct these messages. So you'll still have to provide parameters, such as saying, if you're trying to transfer assets from parachain to parachain, or from a different blockchain to the Polkadot relay chain, for example, you'll still have to say what asset you want to transfer. You'll still have to say which chain you'd like to go to, which account you'd like to deposit assets to. So there's a few things that you still need to fill in, but it's much easier than constructing a message manually. Another thing that's very important and very innovative with XCM is that we want this protocol to evolve and to grow, to add new features, right? And so that's enabled in part by being forwards and backwards compatible. There are over 100 teams that are building in the .sama ecosystem, and all these teams are based all around the world. Some of them are DAOs, some of them are companies, some of them are foundations. And if we tried to coordinate all these different teams to upgrade their blockchains at the same time, that would be a nightmare. And so XCM being forwards and backwards compatible means that no matter what version your chain is running, there's no problem in interpreting that message. So what this means in practice is that if there's a new feature released, for example, and your chain already upgraded, let's say, and another chain didn't, maybe that other chain won't support the new feature, but at least it will still know how to interpret that message. So it won't fail. It won't fail to interpret the message. And forwards and backwards compatibility is huge for enabling the spec to evolve, right? And finally, XCM is also lightweight and efficient. It's designed to be run in an on-chain manner, and so the execution resources for executing these messages and taking action have to be carefully designed so as to not waste the limited resources on-chain. So before you can send an XCM message, you do have to have a channel set up. And the way to do that, well, first, is to consider what type of message is being sent and what type of message passing there is. So the first one is vertical message passing. And that's when you're communicating from a parachain to the Polkadot relay chain. So we call that vertical message passing. There's a channel open by default. There's actually 2 channels open by default between each parachain and the Polkadot relay chain. And because XCM channels are one-way means of communication, if you want to have back and forth communication, you do have to have 2 channels open. And the other type of message passing that we have is cross-chain message passing, or XCMP. And XCMP, you'll see, is designed, it looks quite a bit similar to VMP, where messages, if you want to send from parachain to parachain, they get routed first through the Polkadot relay chain. And the reason for this is that this is kind of a stopgap solution. In the future, you'll be able to send messages directly between parachain to parachain, just one stop, without any additional hops. But right now, all the messages right now are routed through the Polkadot relay chain. And this doesn't really add much developer complexity or anything right now. However, in the future, this will just be faster and more efficient when we have direct chain-to-chain without going first through the Polkadot relay chain. And for the exact mechanics of setting up an XCM channel, so if there's another blockchain that we'd like to open a channel with, we have to talk to them. We have to do some testing on various different test nets. And the exact mechanics are the proposing chain. So the origin chain will say, hey, let's open this channel. And then that channel has to be accepted by the destination chain. So again, to open channels both ways, each team will have to propose one channel opening and accept the other person's channel. So I wanted to give an example of what this looks like in practice. And what this looks like in practice is, let's say, for example, that you want to transfer your native Polkadot tokens, so the native token of the Polkadot protocol, to Moonbeam. Now, typically, you'll be interacting with a wallet or a front end or a dApp, and you may not be worried about the underlying technical details, but it is cool to look at them and consider them just to see how everything works under the hood. So if you wanted to transfer Polkadot tokens to Moonbeam, you initiate a transaction, so you sign it with your Polkadot.js extension or whichever other account management or injected account system you're using, or wallet. And the first thing that happens, let's say you're transferring 5 DOT. The first thing that happens, those 5 DOT are transferred to Moonbeam's sovereign account on Polkadot. And a sovereign account is exactly what it sounds like. It's a special type of account. It's not owned by any one person. And funds can only move from this account via valid XCM instructions. So this special type of account, it doesn't have any private keys, so it can't be compromised. And it's owned essentially by Moonbeam. So it's owned by another blockchain, and it's a sovereign account on another chain, in this case, the Polkadot relay chain. So Moonbeam will recognize this deposit to the sovereign account, and the funds will be locked in the sovereign account. And then Moonbeam will mint a derivative asset called XC on Moonbeam. And then you can do whatever you want with your XC. And we'll learn in just a sec about what you can do exactly with that. At any point in time, you can head back to the Polkadot relay chain and get back your original DOT asset. There's no funny business going on. This is all one-to-one backed. And you don't have to be the original transferer. You can acquire these XC assets, and you can get back the original DOT token at any time. And so the way this works under the hood is that programmatically, your XC tokens are burned, and the Moonbeam sovereign account will then release those native DOT tokens for you to use back on the Polkadot relay chain. So we've covered transferring assets, but what can you do with your XC20 assets, and why is this such a big deal? And first of all, let me back up. What are XC20s? So Moonbeam introduced this new asset class earlier this year, and XC20s are substrate native assets. So that means they're natively compatible with XCM. So that's quite cool. Importantly, they're also compatible with the ERC20 interface. And this is not a compromise. These assets are 100% compatible with the entire ERC20 interface. So anything that you can do in DeFi, any sort of applications or yield farming or trading or borrowing and lending, you can do that all with these XC20 assets. There's no sort of conversions that you need to do. These XC20 assets work in DeFi straight out of the box, and you can access them through the ERC20 interface. And they work with familiar tools like ethers.js and web3.js and the like. So I want to do a quick demo of showing you how you would transfer funds via XCM, and this is what most users would be doing. So let me just show you real quick. So first thing I'm going to do is I'm going to go to apps.moonbeam.network, and I'm going to zoom in so that everyone can see okay. This is the web interface for interacting with Moonbeam and managing all of your assets. So here we have 4 different assets on Polkadot. We have Glimmer token, which is the native token of Moonbeam. And you can see right now we have a balance of 0 DOT. And so let's say we'd like to deposit some DOT. So we can go ahead and press deposit. And we'll see the chain that we'd like to deposit from. And it's going to look through our accounts in the Polkadot.js extension. And I have an account selected here. And I can read my balance here. Let's say I want to bring over, let's say 1 DOT. So I'm going to go ahead and press send. And I'm going to be asked to confirm my password in the Polkadot.js extension. So I'll do that real quick. And my transaction will go ahead. And we'll see the assets have already shown up here in apps.moonbeam.network. Now I transferred 1 DOT, and you can see that I received 0.991. I can zoom in a little bit. So there's a tiny bit of amount taken out just for execution fees. But you can see how easy that was. And you can see that this deposit was done via the Polkadot.js extension. If you'd like to take your Polkadot assets back to the Polkadot relay chain, you can do that at any time by pressing withdraw. And we can choose the max amount in this case. And we can go ahead and press send. And in this case, you'll see that we're confirming the transaction in MetaMask. And this is because the assets are moving first from the Moonbeam network back to the Polkadot relay chain. So we're confirming this transaction on the Moonbeam network. So that's why we're using MetaMask here. We'll confirm the transaction. And our assets will be arriving very shortly back on the Polkadot relay chain. So it's as easy as that. And there are Solidity interfaces for developers to build this functionality into their apps. So this could be in a wallet. It could be in another front end. You don't have to use apps.moonbeam.network. So I want to take a quick look at where we are today. But this is not just going to be a status update of where we are today. Because this is the Metaverse Summit and we're always forward-looking, we'd like to look at where we're going, right? And so I'll start first with an update of where we are. And Gregory Leno from the Akala team has built a fantastic app here that shows you all of the different XCM channels and all of the different parachains and how they're connected. And it goes into detail showing, you can see ones with dotted lines. You can see ones where there might only be one-way connections at the moment. And dotted lines represent proposed connections. So they still need to be accepted by governance and by the community. And another prerequisite to note is that before Moonbeam or Moonriver, before we can open up channels with other chains, they do have to be sufficiently decentralized. And as I mentioned, there's a decent amount of testing that goes into making this possible. So testing on testnets, and we also have to figure out what to set the fees at. We have to make sure that the amount of fees are commensurate for the chain and for the particular asset and things like that. We have to make sure that that's set in an efficient manner. And this is something that's changing on a weekly basis, perhaps even a daily basis. So if you go and check this website today, the connections might look slightly different. And as you could see before, there are fewer XCM connections here and XCM channels on Polkadot. That's because Polkadot is a newer network. Moonriver has been around since last August, and Moonbeam has been around since January of this year. So we expect the number of channels and parachains to grow on Polkadot, of course, and so you'll see the Polkadot side grow as well. So this is not a theoretical or an abstract talk. There's a huge amount of practical adoption that's taken place with XC20s today. The first example that I have to share is Moonwell. And Moonwell is a lending and borrowing protocol. It launched on Moonriver, and it recently launched a deployment on Moonbeam called Moonwell Artemis. And they've accumulated something on the order of $185 million worth of assets in the protocol in total. And that includes, among them, XC on Moonbeam and XCKSM on Moonriver. And so with this, you can lend and borrow your DOT asset. And I would note that this is a major milestone for the DOT asset. So DOT is a substrate asset. It's been around for quite some time. But the major use cases of DOT have been twofold. One, to put in staking, and two, to support the various layer ones that you'd like to see launched on Polkadot. You might want to lock up your DOT tokens in a crowd loan and support these teams in getting and securing a parachain slot. So that was kind of like the major use of the Polkadot token. But the major innovation here is that this is the first time that these DOT tokens have been able to be used in DeFi. And as you know, being able to be used in DeFi in an EVM-based environment opens up a huge host of possibilities. There's tons that you can do, unlimited number of possibilities. So in addition to lending and borrowing, we also have liquid staking enabled by Lido. So Lido, as you may know the staked ETH product, Lido introduced a staked KSM token as well as a staked DOT token. And there are two major things here. One is that STKSM or ST-DOT, they're both accumulating staking rewards of the native token. And secondly, these are assets that can be traded at any time. So for Kusama, you have an unbonding period of about 7 days. For Polkadot, it's about 28 days. And so typically, if you were just staking that native token, you'd have to abide by this long unbonding period. But not so with Lido. With Lido, you can put these assets into DeFi, you can trade them, you can do whatever you want with them. You have instant liquidity. And finally, of course, well, not finally, but the final major example is trading and farming on DEXs. So that includes StellaSwap, which is the largest DEX on Moonbeam, and SolarBeam, the largest DEX on Moonriver. And these are just a couple of examples of what you can do with your XC20s. So Moonbeam's interoperability in terms of connecting with other parachains on Polkadot is enabled by XCM. And so what this means is that you'll be able to take advantage of functionalities on other chains. And other chains are still growing and developing and releasing features and things like that. So it's still early. But you'll be able to take advantage of these functionalities, such as privacy, decentralized storage, decentralized identity, and things like that. So as an example, and this is a forward-looking example, is let's say there's a privacy chain, right, on Polkadot. And let's say you're on Moonbeam, and let's say you'd like to make a private swap. Well, via XCM, you'll be able to make a swap on this other parachain without ever having left Moonbeam, without ever having to go and accumulate the assets or the native token for this other parachain. You can pay for the fees in perhaps Moonbeam, in perhaps DOT, and then this private swap can then take place on the other parachain and then deposit your assets back to a new address on Moonbeam. So that's just one possibility that I wanted to share. And we're not just focused on interoperability inside of Polkadot, but also interoperability outside of Polkadot as well. And so I want to show you a couple examples of where we're going. This is very close to the last example that I just showcased, But let's say you're on another parachain, and let's say there's a smart contract on Moonbeam that you'd like to interact with. Now, you may not have Glimmer, which is the native token of Moonbeam. You might not know about Moonbeam. You might not have ever transacted on Moonbeam, but you can take advantage of a particular contract on Moonbeam by making a remote call via XCM. Now, this has a perhaps limitless number of possibilities within kind of guarded guardrails, for safety, allowing you to do specific things. It's up to the destination chain to let you know exactly what you can do and what you cannot do. But again, the idea is that you could be on a remote parachain and you want to interact with a feature that's available on Moonbeam. Or vice versa. You could be on Moonbeam and you'd like to interact with a feature that's available on another chain. And so you're starting to see a vision where Polkadot is acting as an ecosystem of connected chains, where the value of these connected chains is not in bouncing from chain to chain to chain, but instead living on a chain and being able to take advantage of the features that are available throughout the whole ecosystem. So we can imagine an ecosystem where the value of it is greater than just the sum of the parts. And as I mentioned, we're not focused just on Polkadot. We're focused on connecting the entire ecosystem of other smart contract chains, other major ones such as Ethereum, such as Cosmos, such as Avalanche. And we envision Moonbeam as a hub for connecting both Polkadot and these other major ecosystems. And that's enabled in part by Axelar and Nomad. And Axelar and Nomad enable general message passing. And I have an example of a contract call here on the right. And it's a bit simplified with only 3 components here. You would want to provide a destination chain. You'd want to provide a destination chain address. So what chain do you want to interact with? What's the exact contract on the destination chain? And then a payload. So what parameters do you want to provide to that contract on the destination chain? And as I mentioned, this is a little bit simplified. There still might be a refund address parameter and perhaps one more parameter. But you can start to see what this cross-chain connected contract future would look like. Being able to connect to these various chains, regardless of which chain you're on, is very, very powerful. And as an example of a use case of where this would take place is, let's start with Uniswap. So Uniswap governance is taking place on Ethereum. However, Uniswap has deployments on a bunch of different chains. And Uniswap will be coming soon to Moonbeam. A community vote took place, and the community decided that they'd like for Uniswap to be deployed to Moonbeam. So it's coming soon to Moonbeam, and we can imagine that there are governance decisions that take place all the time, but these governance decisions, they have impacts not just on the Ethereum chain, but also on chains like Moonbeam. So we can imagine a world where a governance decision is made on Ethereum, and then an action has to be dispatched to Moonbeam or to another parachain or another blockchain, and enacted on this remote chain. And so this is possible and will be possible via connected contracts and via this idea of general message passing enabled by Axelar and Nomad. I want to thank you so much for your attention today, and thank you so much for joining us here. And I wanted to give a shout out to our future talks. So Derek Yu, the founder of Moonbeam, has a talk at ECC. Alberto Vieira, developer relations manager, has a talk Wednesday. He has a workshop July 20th. And then I have a talk at Paris Dot on Wednesday as well. So hope to see you at some of these future events. And if you want to stay in touch with us, here is our contact information. Thank you so much.